So to do this worksheet with the dot and cross diagrams, we're going to draw essentially our Lewis structures to figure out how they would bond with each other. So this first one is hydrogen bonding to itself. So you can see in my dot and cross diagram, it starts out giving me two H's there. I'm going to look at my periodic table, and I'm going to know that hydrogen has one electron, and that one electron is in its outside ring. And in order to be stable, hydrogen needs two electrons to fill that ring. So when I'm looking at this dot and cross diagram right here, I'm going to take the one electron that goes with my hydrogen on the left and put it in as a dot, and my one electron that goes with hydrogen on the right is going to go in as an X. And if those two hydrogens are able to share those electrons and keep them in the middle like that, then they are both happy and feel like they have a full energy level. If I wanted to show that formula with lines for my bonds, it would look like an H and an H and a single bond in between them. You have a single bond because you have one pair of electrons being shared. For chlorine has 7 valence electrons. It's in group 7 over here. So before I start trying to put it on my dot and cross diagram, I might want to just remind myself, when I do a Lewis structure, it has 1, 2, 3, 4, 5, 6, 7. So I have 3 pairs on 3 sides, and then I have one single one on the other side. And if I wanted to figure out where those two chlorines are going to fit together like puzzle pieces, it's going to be here where I have this empty space for another chlorine to click in. So I'm going to take that empty space, and that's what's going to go in the middle of like my Venn diagram circles here. So for my chlorine, I'm going to have one electron here that is going in that shared space. And then I have 1, 2, 3, 4, 5, 6. So if I look right now, I have my 7 valence electrons for chlorine. I'm going to switch my colors and switch to an X for my other chlorine on the right-hand side. And that's going to look kind of similar, but a little bit like the mirror opposite. So I have 1, 2, 3, 4, 5, 6, and then my 7th one is going to go here in the middle. So if I look at my circles now, this chlorine has 8 and is happy, and this chlorine has 8 and is happy. So everybody's happy, their outer layers are full. So when I go to write out my formula with the bonds, I have one pair of electrons being shared, and so that means I have a single bond. So I would write it, my element symbols, with a single bond in the middle. Now I'm going to take that hydrogen and that chlorine that I just looked at in the first 2 problems, and I'm going to put them together to make HCl, hydrogen chloride. So we said hydrogen has 1 electron, and chlorine has 7. So if I set it up like that, I have my puzzle pieces clicking in together. My chlorine, whoops, that's the wrong color. My chlorine thinks it has 8 electrons. My hydrogen thinks it has 2 electrons. They both think they have outer energy levels that are full, so they're both happy. Over here, I would write that out as HCl, and because it's one pair of electrons being shared, it is a single bond. For H2O, so we know from all the previous ones that my H has just one single dot in its Lewis structure. Oxygen, if I look at my periodic table, has 6 valence electrons. So oxygen is going to have 1, 2, 3, 4, 5, 6. And I'm going to see I have a spot here where I can add another one and plug it in, and I have a spot here where I can plug it in. So I'm going to kind of take that Lewis structure of the oxygen and just kind of tilt it a little bit so that my H's and my O's are kind of lined up how they are in this Venn diagram here. So my hydrogens have 1 valence electron to share here and 1 to share here. And then my oxygens have 6. So I'm going to have 1 oxygen that I share with that hydrogen and 1 oxygen that I share with that hydrogen. And I need to place 4 more. So I'm going to do 2 over here and 2 over here. So now looking at it, this oxygen thinks it has 1, 2, 3, 4, 5, 6, 7, 8. So that oxygen is happy. The hydrogen on the left thinks it has 1, 2. So that's happy. The oxygen on the right thinks it has 1, 2. So that's happy. And then it shows us here, I would draw it with an O in the middle and then 2 H's. And because that O shares 1 pair of electrons with each hydrogen, it has a single bond with each hydrogen. My last one here is carbon tetrahydride, which is also called methane. So we know that my hydrogens have 1 dot in their Lewis structure, and if I look over here on my periodic table, carbon has 4 valence electrons. So it has 1, 2, 3, 4. And so when you're looking at carbon, it has 1, 2, 3, 4 empty spots where I can plug in those hydrogen atoms. And so if I look at how they have the little Venn diagram circle set up for me, I have 1 hydrogen on each side. So I'm going to go through and I'm going to give each of my hydrogens their 1 electron. And then I'm going to give carbon its 4 electrons, and it's sharing 1 each with those 4 hydrogens. So if I look at my orbitals, this hydrogen thinks it has 2, so it's happy. This hydrogen thinks it has 2, and that one's happy. This one's happy with 2, and this one's happy with 2. And then if I look at my carbon, it thinks it has 1, 2, 3, 4, 5, 6, 7, 8. So that carbon is happy too. And then if I wanted to draw it out with my bonds, at each connection, carbon is sharing 1 pair of electrons with each hydrogen. So those are all single bonds.